As we think about light, we'll often be interested in how it reflects off the surface, and in this case, we'll be thinking about a plane mirror. So before we hit this example question, let's take a look at what if my plane mirror was flat. And let's get a few terms in here. What I've just drawn is the normal, and the normal makes a right angle with the surface. And let's say a light beam comes in, it'll hit, and then it'll reflect. And we know from our notes that the angle of reflection is equal to the angle of incident, and this is measured from the normal. So let's say it comes in at 20 degrees, then my angle of reflection would also be 20 degrees. Now let's take a look at this question right here. It says find the change in direction for the light. So if I were to go back to this light beam would continue going this way. And what I'm looking for is, well, its direction changed to going this way. So it's going up here now. So I want to know this angle that it would make. And hopefully you see, but maybe not, that this is going to be a 140 degree angle that has changed. And let's see why. Over here would be 180 degrees, which means over here would also be 180 degrees. So I would do 180 minus the 20 from here and minus the 20 from here. And that gives me my 140 degrees. So let's keep that in mind. Now, in this problem, we have our mirror at an angle. And before we get too far into it, let's review some geometry. So let's say I have two parallel lines and a transversal going through them. And let's say this angle right here is 20 degrees, like my example over there. Then by alternate interior angles, this angle is also 20 degrees. And by vertical angles, this one is 20 degrees. So let's go to our problem, and let's say that the angle my mirror is making with the horizontal is 20 degrees. Now I'm going to make this plane surface really clear. Here we go, alternate interior angles. So this is 20, which means my angle of incident is 70 degrees because it's made with this normal, which means my angle of incident or reflection is 70 degrees, which means over here, this is also 20 degrees. Now it says find the angle or the angle the reflected light makes with the horizontal. Well, this is the horizontal right here. And this is the horizontal. So I have, it's not going to be 20 degrees. But if we take a look carefully, hopefully we can see that if I extend this angle here and this angle here, they're vertical. So this is 20 degrees. So if I'm looking for the angle that the reflected light makes with the horizon, it's going to be that angle, which is going to be the sum of these two pieces, 20 plus 20, which is 40. And then it asks for the change of direction of light. Now, in this case, originally it was going this way, and now it's going this way. So my change in direction in this example is also 40 degrees. Let's try another one, and let's say I have down here 35 degrees. Now again, I'm going to make this surface really clear, and we have alternate interior angles right here. So this is 35 degrees. The normal makes a right angle, so that means this is 55 degrees, my angle of incident. So my angle of reflection is 55 degrees, and the angle that my reflected light makes with the mirror is 35 degrees. Now, by vertical angles, this and this are the same, so we have 35 degrees. So the angle that I'm making with the horizon, which I've drawn right here, but you will probably have to draw it yourself, is going to be 35 plus 35, which is going to be 70 degrees. So let's take a look at another example, and let's say now my mirror is angled, but also the light beam that I'm thinking about is also at an angle. So we see it right here, and let's say it's coming in. Now I'm going to need to know the angle that is coming in. Let's say it's coming in at 42 degrees. And let's say that the angle made at the table, let's say that is 30. Do I want it to be 37 degrees? Nah. Let's make it, just 30 degrees. I think that'll be better. So I'll get the eraser. We'll just make that 30 degrees. That'll make for a better example. Okay, so 30 degrees. So let's see what we can figure out here. So I'm going to make the surface of this very clear. If my angle of incident is 42, well then my angle of reflection is also 42. Now this is 90 degrees, but notice since my light didn't come in parallel, I'm going to have also this little piece right here. Okay, so this angle right here is 30 degrees because of alternate interior angles. Now by vertical angles, this angle right here, hopefully you can see that these are vertical angles. This is also 30 degrees. Now since the normal makes a right angle right here, we know that this is going to be 90 minus the 42, which is going to be 48. So this is 48. Now once the angle that the reflect light makes with the horizon, so here's my horizon, and this would be the angle that it makes with it. So that is going to be 48 plus the 30, which gives me a 78 degree angle that it makes with the horizon. But I also asked for the change of direction. Now this was going down like here. So this green, which is representing my incoming light, was going this way. But now it's going this way. And there's a lot of different ways that we can figure this out. But basically, what we want is now all of this. So I'm going to think of this again as a flat line. And I'll clean it up over here. So what we have is this line is my light coming in. And I have a normal right here. Doesn't look normal, but that's because I'm copying this diagram a little bit. And then this is 42 again. And what we're asking for is this angle right here. So I'm going to come back over here. Now we see this one and this one. And I'm going to do, to get this big arc right here, 180 minus the 42 minus another 42. So that's going to be 180 minus 84, which gives me, I believe, 96. Yes, so this is 96 degrees. All right, let's try another example of that. We'll clear off all this. And let's say my angle of incident coming in, let's say that's 30 degrees. And let's say the angle that my mirror is making with the horizon, let's say that's 20 degrees. It's not theta though. So I'm going to make my table surface really clear right here. Now the green is the incoming light, so it's going down this way. But it gets reflected. So my angle of incidence is 30, which means my angle of reflection is also 30. And since the normal makes a right angle, I know that this is going to be 60 right here. I'm going to extend my horizon a little bit. And by alternate interior angles, I know that this one is 20 degrees. And by vertical angles, I know that this one over here is going to be 20 degrees, this angle. So let's first answer, what does it make with the horizon? Well, the angle it makes with the horizon is going to be this, and that's going to be 80 degrees, 60 plus 20. The next thing it's going to ask is, what is the change in direction of light? So the light was going down here, so the change in direction is this. It's coming up here now because it's been reflected. So I'm going to look at this as basically a flat line. That's my incoming light. And I have a section over here where there's essentially 60 degrees. This 30 and this 30, which means this part over here is got to be 120 degrees. So this is 120 degrees. And hopefully you can see it right here. Here's that flat line. That was my incoming light. And then I have 30 and 30, and that will give me 60. Subtract it from 180, gives me 120.